Hi everyone, welcome back to this channel. Last class let's complete the P block elements, so that part is belongs to your inorganic. Before that we end up the or completed the alcohol, phenols and ether. It is a part of organic chemistry. The next part of alcohol is nothing but aldehydes, ketones and carboxylic acid. Again, it is a huge topic for your second year, and it's a very important topic under the organic chemistry. Alcohol, phenols, ethers and aldehyde, ketones, carboxylic acid. These six part plays an important role, and it is the very important topic for your study, organic study. Okay, so all basic things will be studied under this topic. The similar things whatever we studied in case of alcohol, phenols and ethers, so similar kind of reactions, similar kind of properties and all the concept, okay, is very similar in this topic also. It is very similar to alcohols and phenols. Okay, let us start with the introduction of aldehydes, ketones and carboxylic acid. The alcohol, phenol and ethers, in that topic we studied the concept of organic chemistry or organic compound contains carbon, hydrogen, oxygen. In that cases, a carbon oxygen single bond is observed. The similar type of things and also observed under aldehyde, ketone and carboxylic acid. The major difference is here we observe carbon oxygen double bond. In aldehydes, ketones and carboxylic acid we observe the carbon oxygen double bond. But in that so alcohol and phenol, carbon oxygen single bond. That means this topic and that one, both compounds or both is the study of the compound contains carbon, hydrogen and oxygen. Here we observe carbon oxygen double bond. Generally the compound contains carbon oxygen double bond in the chain or in the compound, then that compound is also known as carbonyl compounds. These are compounds are commonly known as carbonyl compounds. These are known as carbonyl compounds. Therefore, combining aldehyde, ketones and carboxylic acid is called carbonyl compounds. These are carbonyl compounds. Not only aldehyde, ketone and carboxylic acid, there are other compounds are also observed under carbonyl compounds. The major compounds are aldehyde, ketones and carboxylic acid. The major carbonyl compounds are aldehyde, ketone and carboxylic acid. Then what is the general formula and what is the general reactions or general things under aldehyde, ketones and carboxylic acid? Here carbon oxygen double bond and carbon is bonded with hydrogen and one alkali group. One alkali group, one hydrogen to this carbonyl carbon. Then that type of compound is known as aldehydes. These are known as aldehydes. If another hydrogen is replaced by another alkyl group, alkyl groups are commonly represented as a dash, R and a dash. So two different types of alkyl groups are same type of alkyl groups are attached to carbonyl carbon, then it is known as ketones. So such type of compounds are known as ketones. And if the hydrogen of the aldehyde is replaced by OH group, alcoholic group, then it is known as carboxylic acid. Carboxylic acids. So these are the general formula of aldehyde, ketones and carboxylic acid. Very simple compounds. Here what are the important things? The carbon contains oxygen or carbon that bonded to the oxygen with the double bond is known as carbonyl carbon. Please remember, it is known as carbonyl carbon. The reason of getting the knowledge about this carbon is during the study of the aldehyde ketones and carboxylic acid, and come across the carbonyl carbon word in many times. Therefore, you should know what is the meaning of carbonyl carbon. Carbonyl carbon means carbon contains oxygen, or carbon bonded with oxygen through double bond. That carbon is known as carbonyl carbon. And compound contains carbonyl carbon, then that compound belongs to carbonyl compounds. Aldehyde, ketone, carboxylic acid are the three major carbonyl compounds. Then what are other carbonyl compounds? Let us discuss about other carbonyl compounds. Okay, carbonyl compounds. First one is aldehyde, carbonyl compounds. Aldehyde. How to represent aldehyde? Carbon, oxygen, double bond. Here alkyl group and another side hydrogen. How many bonds on carbon? The covalency of carbon is 4. One is with alkyl group, another is hydrogen, and other two with oxygen. Okay, it is aldehyde. Next, ketone. The next carbon compound is ketone. Here, carbon oxygen double bond. One side one alkyl group, another side another alkyl group. It may be same or it may be different. Next, carboxylic acid. Carboxylic acid. What is the meaning of carboxylic acid? Carbon contains oxygen, one side alkyl group, long chain alkyl group, and another side hydroxy group. Another side hydroxy group or alcoholic group. Okay, alcoholic group means OH, hydroxy group. The next is acyl halide. Acyl halides. Acyl halide or acid halides. Here, carbonyl carbon contains, one side contains H or R alkyl group, and another side any halogen. It may be Cl or it may be bromide, like that. Okay, X is halogen, chlorine, chlorine, bromine, iodine. So major compounds are with the chlorine and bromine. That's why mainly we call it as chlorine and bromine. X may be chlorine or bromine. You can call it as halide, any halide. X is halide. So it is another type of carbonyl compounds. Here also we observe carbon oxygen double bond. That's why we call it as a, or belongs to a carbonyl compound. Okay. The next, this moiety or carbonyl part is attached with ammonia derivative. Ammonia derivative means amines and like that. At that condition, or at that time, we call it as, the compound is known as NH2. Suppose NH2 is attached to carbonyl. The NH2 moiety is attached to carbonyl carbon, then we call it as amide. It is a general formula of amide. Next, here R group, here little bit change is observed, and that change is C double bond O. Okay, what happened in this case? Two carboxylic acid, they join with the loss of oxygen and hydrogen. So loss of hydrogen, anhydride acid anhydrides, anhydrides, acid anhydrides. So it is also a type of carbonyl compound. Similarly, there are different types of carbonyl compounds are observed. Then what is the important what is the importance of these carbonyl compounds in the carbonyl compounds are majorly distributed in the animal and plant kingdoms. Suppose we consider mainly a pleasant fragrance substances or a pleasant smell substances like vanilla. So in vanilla beans contains vanillin. So it is the derivative of the carbonyl compounds or the derivative of aromatic carbonyl compounds. Aromatic compounds, carbonyl compounds. Similarly, cinnamon. Okay, in cinnamon also it has a pleasant smell. Okay, so that compound also contains carbonyl compounds. Salicylaldehyde that is present in mainly pleasant flowers. So contains salicylaldehyde. Salicylaldehyde is a hydroxy derivative of benzaldehyde. So benzaldehyde is again it is belongs to this carbonyl compound, aldehyde compound. Okay, is a derivative of aldehyde. The mainly the pleasant smell compounds contains the derivatives of aldehydes ketones. Acetone is also a type of a ketone, so again it has a pleasant smell. So the mainly aromatic derivative of this carbonyl compounds, and all type of this carbonyl compounds is observed in or distributed in different types of animals and the plants. In different types of animal and plants or animal kingdom and plant kingdom, so they contains derivatives of the carbonyl compounds and plays an important role in plant kingdom and the animal kingdom. So therefore the study of this compound is very important. Okay, study of carbonyl compound is important, knowledge about the carbonyl compound is very important. So therefore this topic is the very important concept in organic chemistry, okay. So let us discuss the aldehydes, ketones and carboxylic acid, aldehydes and ketones. Okay. Carboxylic acid will be discussed after the completion of aldehydes and ketones. Okay, that part is a little bit different than the aldehydes and ketones. There are a lot of reactions observed in aldehydes and ketones. Okay, let us start with the nomenclature of aldehydes and ketones. Nomenclature of aldehydes and ketones. Then under the nomenclature, we observe two different types of nomenclature. One is common naming system, and another one is IUPAC system. In case of the naming the aldehydes and ketones and also carboxylic acid are better in case of carbonyl compounds. Okay, in case of carbonyl compounds, during the nomenclature of carbonyl compounds through common naming system, we use different types of prefixes. Prefixes means prefix the word which is used before the root word. There are different types of prefixes if we observe. The carbonyl carbon is considered as carbonyl carbon is considered as mainly it is considered as a alpha carbon in aromatic case. Okay, alpha carbon, and the very next carbon is known as a beta carbon. So it is in case of aromatic compounds. Aromatic compounds. Next, the in case of aliphatic compound, suppose we consider aldehyde. The aldehyde substituted carbon. The very next to this carbon, aldehyde not a aldehydic carbon. So aldehydic functional group, that attached carbon. The attached carbon is considered as alpha, and very next to it is known as beta. Next carbon is known as beta. Similarly, gamma and all that. The alpha, beta, gamma or alpha, alpha dash, beta, beta dash. Suppose if carbon contains two substituent, these are prefixed with alpha notation. Okay. So what is the importance of this? During the common naming of aldehyde or ketone derivatives, the aldehyde or ketone derivative, ketone functional group attached carbon is considered as alpha. If this carbon contains any methyl group or any R group, okay, clearly observe the substituted functional group substituted carbon contains methyl group, then this methyl group is prefixed as alpha methyl, or it contains the higher substituent means functional group, second priority functional group or third priority functional group. The lower priority than the aldehydes or ketones or carboxylic acid, this hydroxy group is known as alpha hydroxy. How to name this compound? Alpha hydroxy. The compound is prefixed, or name of the compound is prefixed using alpha hydroxy during the common naming system. Suppose the hydroxy group is attached with third carbon, 1, 2, 3, then it is beta hydroxy. Next carbon, gamma hydroxy. Okay, here during the common naming system we don't use any numbers, 1, 1 or 2, 3. These numbers are used in case of IUPAC system. In place of a number, here during the common naming system we use alpha, beta, gamma notations during the common naming system. This part is prefix of the common name. Please remember all these things. It is a very important thing during the nomenclature of the aldehydes and ketones. Okay. Next, what is the importance in IUPAC system? What are the things are there? In case of IUPAC naming system, we replace the E by, for aldehyde use L. Okay, E is replaced by Al, or in case of it is for aldehyde, it is for aldehydes. If a compound contains aldehyde, then the last E, ane or een or ein, at that condition we come across the word letter E at the last, correct? ene, ane, the last E is replaced by the functional group. Suppose it is a aldehyde, then al. Suppose it is ketone, then E is replaced by one, not one, one for ketones. Okay, E is replaced by one, E is replaced by al for aldehyde. Okay, so we don't suppose during the nomenclature of the compound, last the word, the prefix words, suffixes are al and on. Suffix of aldehyde is al, suffix of ketone is on. Okay, so these are the important things we should remember during the nomenclature of the compound. Okay, let us start, or let us discuss the nomenclature of a few compounds. Okay, first aldehyde. CH3 CHO. What is the first member of aldehyde? What is the first member of ketone? Okay, I like to start the first member of aldehyde. The first member of aldehyde means carbon and carbon contains hydrogen at one side, another side alkyl group. Alkyl group means it may be hydrogen. Okay, suppose the alkyl group is hydrogen. Suppose alkyl group is hydrogen. Then what is the name of the compound and what is the formula? How to write the same compounding formula? H here H CHO CHO. Why CHO? Why we use CHO? CHO is the functional group, right? A general way of representation of aldehyde. Functional group of aldehyde is CHO. Here substitute group is hydrogen. The alkyl group should be substituted. If in place of alkyl group hydrogen is substituted, then it is HCHO. The first member is HCHO. HCHO. Okay. Now what is the name of, what is the common name? The common name of HCHO is, the first member of aldehyde is nothing but formaldehyde. What is the name of the, what is the common name of this compound? Formaldehyde. Formaldehyde is the name of the first member of aldehyde. The next, IUPAC system. In case of IUPAC system, how to name this compound? It contains the aldehyde. Aldehyde functional group is observed, therefore we should use Al. The next, how many carbon? One carbon. For one carbon, the root word is with. It contains single bond, carbon, singly bonded with alkyl group and hydrogen, not with oxygen. It is not considered. Okay, only the chain. Chain contains single bond, therefore methane. Actually, it is methane, but contains aldehyde group, aldehyde functional group. For aldehyde functional group, we use suffix Al. Al should be replaced E. E is replaced by Al. Therefore, it is methane. Okay, let us discuss the second example. Okay, CH3. Okay, here hydrogen is replaced by the first alkyl group. Alkyl group R group are CH3, C2H5, so the homologies of alkenes. The first is CH3. If CH3 is replaced with hydrogen, then what is the name of the component? How to represent CH3? CHO. CH3 CHO. And what is the name of this compound? CH3 CHO. How many carbon? 1, 2. 2 carbons. Therefore, it is, in case of IUPAC system, 2 carbon compound is it contains single bond ane. It contains the functional group aldehyde, therefore E is replaced by Al ethanol. Clear? E is replaced by Al substituent, or sorry, functional group. Next, during the common naming system, how to name this compound? It contains 2 carbon. For that we use acetaldehyde. It is acetaldehyde. Okay. Next, CH3 CH3 CHO. Here, observe here. CH3 CH3 CHO. What happened? This Okay. Alkyl group is CHO, CH. Here there is 2 CH3. If the compound is like that, here CH, CH3, CH. What is the name of this alcohol? What is the name of this alcohol? What is the common name of this alcohol? What type of compound it is? I am giving the one trick to identify the iso, correct? If carbon contains functional group, it may be a long chain or it may be directly a functional group is attached. And this carbon, corner carbon contains CH3. CH3. Carbon contains 2 CH3. The corner carbon contains 2 CH3 groups, methyl groups, and contains long chain or directly functional group is attached to this carbon. Then such type of compound is prefixed iso. Okay, so similar kind is observed here. See, 2 CH3 groups attached and functional group is attached. Because of that, it is iso. Iso. How many carbon? 1, 2, 3, 4. 4 carbon. Butyraldehyde. Butyraldehyde. Isobutyraldehyde. 4 carbon, therefore but. What is the IUPAC's name? How to give the number? First select the long chain. Long chain is this chain is longer, this one is also, both is correct. And numbering. Number should start from the carbon contains functional group. It is 1. It should get least. This carbon is also included during the naming. Please remember, in case of aldehyde, the aldehyde carbon, functional group carbon, is also considered during the numbering. 1, 2, 3. If it is long chain, 1, 2, 3. If it is long chain, 1, 2, 3. Second carbon contains CH3. Second carbon contains CH3. Therefore, long chain contains 3. Second contains CH3. CH3 is lesser substituent, lower priority. It becomes prefix. 2 methyl. 2 methyl. Next, 2 methyl. Total number of carbon 3. Pro contains single bond in propane. 2 methyl propane al. Propanal. It is the IUPAC. See name. Okay. Next, I'd like to take ketones. Okay. After that, we will move on to the aromatic compound. Ketone, the first member of ketone. So these are 3 example for aldehyde. Ketones. What do you mean by ketones? Ketones means carbonyl carbon. Carbonyl carbon means carbon oxygen double bond. Carbon oxygen double bond contains R and R dash. Contains 2 alkyl group. 2 alkyl group. On both sides we observe the alkyl groups. Therefore, I am consider CH3 if R and R dash both are same, R equal to R dash, and it is CH3. It is CH3, CH3, CH3. Oh, this is the first member of ketone. Okay, this is the first member of ketone. Then what is the name of this ketone? The common name of the ketone is a very general name or famous name. It is acetone. The name of the compound is acetone. This is general name. Acet because of CH3 is attached, correct? CH3 is attached, therefore as yes used. Acetone, on because of ketone. That is the IUPAC, common name. Then what is the IUPAC name of this compound? IUPAC name of the acetone is How to give the number? Select the long chain. This is the long chain, and numbering. Here the ketone is not present at the, or function group is not present at the corner carbon. Correct? It is present in the middle. Therefore, numbering start with the carbonyl carbon. Which one is carbon number? Sorry, number is start from carbon contains carbonyl carbon. Carbon contains carbonyl carbon. This is the carbonyl carbon. Which carbon contains carbonyl carbon? Both. This contains carbonyl carbon, this contains or attached to carbonyl carbon. Therefore, number is, you can start the number anywhere. Okay. 1, 2, 3 is also correct. 1, 2, 3 is also correct. But the carbonyl carbon should get least number. Suppose you are going in this way, carbon get number 2. You coming from this side, carbon get 2. Therefore, both the case same. Therefore, there is no worry. Suppose it contains long chain, at that time, please remember, ketones contains long chain in both the side. Then the number should start from the carbon very near to the carbonyl carbon. Long chain, but little bit smaller here. Then we should number the carbon from this side. Suppose it is smaller, then we should give the number from this side. Okay, this is the very important concept during the numbering. Next, how to name this acetone? 1, 2, 3. Second carbon is the carbonyl carbon. Second carbon is the ketonic carbon. Okay, therefore it is contains pro 3 carbon pro, where we observe the ketone on second carbon. Therefore pro 2 1. Pro 2 1 is the 1. Here we should use E. It is must and should. Okay, O-N-E. Okay, E is replaced by propene, or propane is replaced by propone. Okay, so this is the way of giving the naming the compound ketones. Okay, the other example we will discuss in the next video. Okay, thank you for watching.